All right, hello and welcome. We're going to go through this calculation that we saw as a little practice on Friday, the 13th. So there was no quiz this day, right? We talked about that. But it's still good fun, good practice. All right, let me get my writing tool handy. All right, we talked about the base units of volume have to be meters cubed. You could think about volume as length times width times height. You could think about the volume of a sphere, 4/3 pi r cubed. You could think about the volume of anything, but you're always going to get cubic meters when you work through what units measure, for example, the radius or the length, the width, and the height for a rectangular prism or whatever it is. Show that the SI base units of pressure are kilograms per meter per second squared. That comes from the fact that pressure is force per area. Force is measured in newtons. Area is measured in meters squared. I mentioned a moment ago that this is called a Pascal. A Pascal of pressure is equal to a Newton per square meter. Now, the base units of a Newton, as we talked about yesterday, are kilogram meters per second squared, right? That's coming from Newton's second law. A Newton of force equals a kilogram meter per second squared. So we've substituted in those base units for the Newton. These meters squared down here allow us to realize that that meter will cancel one of those, and we're left with kilogram per meter per second squared down in the denominator, and that agrees with that. So far, so good. If you need a moment or two longer to get any of that down, just go ahead and pause the video and take your time. All right, welcome back. On to the fun one. The volume of liquid that flows through a pipe in time t is given by the equation here. T is the pressure difference between the ends of the pipe of radius r, length L. The constant C depends on the frictional effects of the liquid. So imagine if it was a viscous liquid like molasses, slows molasses, or if it's like water, it flows more readily. So it makes sense that friction would have something to do with that. Let's work through it. On the left side, now all we care about is the units of C. That's what we're trying to solve for. On the left side, we've got volume per time. Just a minute ago, we said volume was meters cubed. Time we know is seconds. Our job is to make the right side equal to this. Pressure, we said, was kilogram per meter per second squared. So I like to use the positive exponents in the denominator. So those are the units of pressure. Radius to the fourth power means I'm going to have units of meters to the fourth power in the numerator from that. Pi and 8 are just numbers. They don't have units, so we can ignore them for this. L is the length of the pipe, and so that's also going to be a linear dimension, right, measured in meters. And so there's already a meter down there from pressure. This length is going to contribute another meter there. And so right away, I can see that those 2 meters will cancel 2 of these. And I can rewrite this as meters cubed per second equals kilogram meters squared per second squared. Now, what are the units of C? So I'm going to plug in the units of C just kind of like this, keeping in mind that C is in the denominator. So right away, I need to get rid of these kilograms. So C must have units of kilograms right there. I need to have cubic meters, not square meters. So I need another meter on top. And I need to cancel out one of these seconds. So I have only 1 second. And so this is what would get plugged in. So what are the units of C? C must have units of kilograms per meter per second. Because remember, as we plug it in, the denominator of the denominator goes back to the numerator, right? And so these that are in the denominator of C move back to the numerator here where we want them. So they combine to give us meters cubed per second. Hopefully that makes sense. If not, try to, go through the explanation again, bring any questions that you have to class. I hope everybody has a good weekend, and we'll see you next time.